This video is part of the MCAT chemistry video course. Subscribe if you'd like notifications about the release of new videos, and visit ancientbrainstutoring.com for questions about MCAT tutoring. In this video, we'll go over stoichiometry and then finish by talking about theoretical yield and limiting reagents. Stoichiometry problems are always about finding an unknown amount of an element or a molecule in a chemical reaction. And to find that unknown amount, you're always going to be given some amount of another molecule or element in that same chemical reaction. So for example, if you looked at our two practice questions here, for the first one, we are looking for how many grams of H2O are produced, and we're given an amount of O2. For the next one, we are asked how many moles of C6H12 would be required, and then we are given an amount of CO2. So they always follow the same pattern of you're looking for some amount and you're given another amount. To find that unknown amount, you're going to use the balanced equation all the time. All stoichiometry problems follow the same pattern where you want to take that value that you're given. So in the first one, we're given 4 grams of O2. In the second one, we're given 3 moles of CO2. You want to take that value and turn it into moles if it's not already in moles. So the second one is already in moles, so you don't have to do anything. But anytime that it's not in moles, your first task is then to convert it into a molar value. And that's going to be doing what we did in the previous video, where you use the molar mass whenever you're given grams, and then other times you're going to be given a concentration, and you're going to have to work with molarity, which that'll be covered in the next video. But regardless, the task remains the same, where your goal is just to find how many moles am I working with. Once you find the number of moles, you're always going to then use the balanced equation to then find the amount of moles of the unknown. So for our practice problem, we need to look at this equation and then first always make sure that it's balanced. And this one is not balanced, so I'm going to put in the coefficients if it were, which would be a 6 at these 3 positions. And we're not going to cover balancing equations in this video. That was covered a couple videos ago, so just rewatch that if you were confused on how we got those numbers. Now we can use the coefficients that we just wrote in. Remember that the balanced equation tells us the ratio of all the molecules or elements in the reaction. So if we can find how much of any one of our molecules in the reaction, we can use that value to then find the amount of any of the other molecules in the reaction by using the ratios of the coefficients in the balanced reaction. So for example, there's an unwritten coefficient of 1 in front of C6H12O6. And if we look at, for example, O2, there's a 6 there. So that means that there is 6 times as much O2 as there is C6H12O6. So if we find the number of moles of the C6 molecule, then all we'd have to do is multiply it by 6, and that's how many moles of the O2 molecule we would have. And we'll do that in our 2 examples here right now. In the first one, we're given an amount of O2 in grams and then asked to find how many grams of H2O would be produced. So the first thing, just like what that first point says, find the number of moles that we're working with. And when you're given a mass of a substance in grams, you find the amount of moles by dividing that mass by the molar mass of the molecule. So first we need to find the molar mass of O2, and it's just 2 oxygen atoms, so the molar mass of that is 32 grams per mole. Now we take 4 divided by 32, and we're going to practice doing this all without a calculator. And 4 over 32 simplifies to 1/8. And the way I would think about this is 1/8 is half of 1/4. So half of 1/4 equals 0.125. So we have 0.125 moles of O2. Now we follow the second point that we made. We're going to use the balanced equation to figure out how many moles of H2O we're working with. So we do 0.125 moles of O2. And then the method that you do is you multiply that by the coefficient of whatever you're trying to find. So the coefficient of H2O, because that's what we're trying to find. So that would be 6 for H2O. And then you put that over the coefficient of what you're working with already. So over 6 for O2. So that's because both of the coefficients are 6. And then what that's just telling us is that for every 6 parts of H2O, it requires 6 parts of O2. So then if we have 0.125 moles of O2, then that would produce 0.125 moles of H2O. Now that we have the number of moles of H2O, we just need to multiply that by the molar mass of H2O. And I just slid everything over so we have more room to work with. So it's 0.125 moles times the molar mass of H2O, which there are 18 grams per mole of H2O. And again, let's really try to work on just doing our mental math here. So 0.125 is 1/8. So I would recommend changing that back to 1/8 and do 1/8 times 18, which that would give you 18 divided by 8. And 8 goes into 18 two times, so we have 2. There would be 2 left over, so 2 and 2/8, which would be 2 and 1/4, which would be 2.25. So there are 2.25 grams of H2O. Now for the next one, we're given an amount of moles, and we're asked to find an amount of moles. So there's not going to be any of the conversions to moles like we did in the last one. This one is easier, and you get right to using the coefficients in the balanced reaction. So we're starting with CO2, and we're trying to find the C6H12O6. So you want to write 3 moles of CO2 is what you're starting with. So you multiply that by the ratio of the coefficient of the unknown first. So that would be 1 C6H12O6. And then do that over the coefficient of the one that you're given. So we're given CO2, and the coefficient is 6. So 6 CO2. So we need 1 C6H12O6 for every 6 CO2. So if we have 3 moles of CO2, we multiply it by that ratio, and that means that we are going to have a half mole of C6H12O6. And just remember that we could take our number of moles wherever, multiply it by Avogadro's number, and then that would give us exactly how many molecules we're working with. So at some point in all stoichiometry problems, and in both of these problems, you're going to be doing the moles of the amount that you're given. So I'll put moles of given. So again, that is the amount of whatever you're given. So in the first one, we're given 4 grams of O2. In the second one, we're told 3 moles of CO2. So this is how many moles of whatever value you're given times the ratio of the coefficient of the unknown first. So I'll put coefficient of unknown divided by the coefficient of the given. And then that will give you the moles of whatever it is that you're trying to solve for. So moles of the unknown amount. And in the first problem, that would be this part of it. And in the second problem, that would be this part. The last thing we're going to look at is limiting reagents. And a limiting reagent happens anytime that one of your reactants runs out before the other one. And the one that runs out is called the limiting reagent because that causes the reaction to stop. And then the one that doesn't run out, so you have extra left over, that one is said to be in excess. And for all of these problems, you're going to have to use a balanced equation, just like before. So in our example problem here, we have an unbalanced equation. It's the same one as before. So when it's balanced, we just need to put a 6 in front of those 3 molecules. In our example, we're starting with 12 moles of oxygen and 3 moles of glucose, and glucose is this first molecule here. And you want to make sure that you're never just looking at whatever has less moles and then picking that as the limiting reagent, because you need to be using your balanced equation at all times to find the limiting reagent. And what you want to do is just pick either one of these. So let's just pick 3 moles of glucose, for instance. And we're going to write 3 moles of C6H12O6. And we're going to multiply this by the same ratio that we are doing in the other stoichiometry problems. So we're going to do the coefficient of the other reactant. So we'll do 3 moles times 6 O2 over 1 C6H12O6. And again, what this term is saying is that we need 6 times the amount of O2 as we do C6H12O6. So when we multiply that out, that means we're going to need 18 moles of O2. And if we look at what we're given, we're only given 12 moles. So that means we do not have enough O2, which means oxygen is the limiting reagent. Once you find the limiting reagent, you can then find the theoretical yield. And the theoretical yield is the maximum amount of product that you can make. And the maximum amount of product will depend on when the limiting reagent runs out. So once that limiting reagent runs out, the max amount of product you can make, that's called the theoretical yield. So we determined that oxygen was the limiting reagent, and we have 12 moles of oxygen. So to figure out how much CO2 we can make, we need to take 12 moles of O2, and hopefully you can kind of predict what we're going to do here. we're going to multiply it by the ratio of the coefficient of what we're trying to solve over the coefficient of what we have. So we do 12 moles of O2 times 6 for CO2 over 6 for O2, which is telling us it's a 1-to-1 ratio. So that means we would get 12 moles of CO2. And the problem would tell you on the MCAT, if you're wanting the theoretical yield to be in moles or grams, we just solved it for moles here. If it wanted it in grams, you do the exact same thing, and then you just multiply the 12 by the molar mass for CO2. Now the last thing we'll look at is percent yield, and the percent yield is your actual amount that you obtain in an experiment divided by the theoretical yield. So the theoretical yield would be under perfect conditions, you're able to obtain every single molecule of product that you create. But in reality, we're going to lose some product in the process of the experiment through various ways. So again, that equation is the actual yield divided by the theoretical yield. So we know the actual yield is 100 grams because that's what the question told us. So now we need to figure out what the theoretical yield would be, but in grams, because we know the theoretical yield is 12 moles. We just need to convert that to grams. So you do 12 moles times the molecular mass of CO2. So first we got to find the molecular mass of CO2, which would be all the atomic weights added together. And that's 12 plus 16 plus 16. And that equals 44 grams per mole. And we do 44 grams per mole times 12 moles. And again, let's just practice our rounding here. So we could round 44 probably to 40. And 40 times 12 would be 480. So that equals approximately 480 grams. We rounded our 44 down. We rounded that to 40. So 480, let's go ahead and just round that to 500. And then that makes our equation for the percent yield way easier. And we would do 100 grams divided by 500. So let's just do that right up here. So actual yield was 100 given in the question divided by 500, which equals 20%. So we have a 20% yield approximately.